Okay, for geometry, we are ready for lesson 7.2, and it is still about similar polygons, but now we're talking more specifically about their corresponding sides. We've talked about this before, so listing the pairs of congruent angles and the extended proportion that relates the corresponding sides for the similar polygons would be right below here. So here are the polygons. Actually, I might have to raise this camera up so you guys can see better. Okay, so here are the two shapes that are similar. Here's pictures of them, and then here are the blanks that we're going to fill in. So obviously angle A is congruent to angle W. So the angles in similar polygons are congruent. So if this were 92 degrees, then this would also be 92 degrees. So the angle measures on similar shapes are congruent. So angle B is congruent then to angle X. I guess I should have put angle. Angle C would be congruent to angle Y. And then angle D would be, it would match up, it would be congruent to angle Z. Okay, now the side lengths though are not congruent. You can tell this shape is smaller than this shape. So even though the angles match up, I should have probably marked these up while I was doing it. So I'm going to go ahead and make these. So these angle measures are congruent. 1, 2, 3, 4. 1, 2, 3, 4. However, the side lengths are on a similar, they're on a ratio, the same ratio. So from side AB over side WX is similar, is equal to the side that matches up BC over XY. And then let's look at what we haven't said yet. We haven't said CD, which would be similar, which would be over YZ. And then lastly, D back to A, and then Z back to W. Okay, so let's look at the second one and make sure that that all made sense. So the angle measures are the same, but the side lengths are similar. They have a ratio, they have a scale factor. So angle G would be congruent to, you know what? You should pause the video and try these on your own and then push play again and make sure you got them all right. Okay, angle G is congruent to angle K, angle H is congruent to angle J, and angle I is congruent to angle L. And then if you look at the matching side lengths that match up, they are GH over KJ equal to HI over JL equal to IG over LK. Okay, so now we're going to start looking at two polygons, and you're going to determine if it's similar. So it's yes or no. And if it says if so, write a similarity statement and give the scale factor. That's kind of new. And then if not, explain. Okay, so this is a 3 to 6. And this is 4 to 8. So I just picked two sides that are corresponding, and I'm going to set them up in two fractions, kind of ratios like we did up here with the side lengths. And if 3, 6 simplifies to, to 4 eighths, that's a 4 here, then it is true. So this would equal half. This would also equal half. So this is yes. So we are supposed to write a similarity statement. I'm only going to make you guys do this once, because once you do this once, you'll know how to do it all. And a similarity statement is this. So in the correct order, we would say maybe C, D, E, F. So polygon C, D, E, F is similar, you have to go in that same order, to Q, R, S, T. Okay, if it's yes, I won't make you guys do that again, but I just want you to know how to do it. You have to just list them in order of their similar, in the right order of their angles. Okay, number 4, I'm going to pick 8/12, and I'm going to set that up equal to, I have to make sure I go in the right order. 8 was the smaller side, and then 12, so 3 to 4. So does 8/12 simplify to 3/4? You can divide both of these by 4, and it would be 2/3. So this is a no. Another way that I've seen people do this that actually is pretty genius is if you cross multiply and write the number up, like 12 times 3, it's 36, and 4 times 8 is 32. So if these numbers are not the same, it's a no. Like, look what we could have done back here. 6 times 4 is 24. 8 times 3 is also 24. So that was yes. So that's a good way to do it as well. So this one's no, and if it says no, explain, but I'm just going to leave it up to you to see that these two do not simplify to the exact same fraction, to the same ratio. This one would simplify to 2/3, and this one would simplify to 3/4. Okay, try number 5. I'm going to do the little side to the long side, the short to long, so 4 to 10, and the other one, short to long, is 3 to 8. Let's do our little, oh, sorry, can't even see that. Let's do our shortcut. 10 times 3 is 30. 8 times 4 is 32. So this is going to be a no because they do not simplify to the same scale factor. Okay. Oh, this one actually said give the scale factor if it's true. So the scale factor is 1/2 in this one because they both simplify to 1/2. Sorry to jump around. Okay, I'm back to number 6. I'm done jumping around. All right, number 6. So I'm going to assume those numbers are the same. So let's still look at the side lengths. I'm going to do the little one with the biggest one. I'm going to leave out the middle one for now. So I'm going to go 6 to 12. So 6 to 12 is 1/2. And the littlest one here is 4. And the biggest one is 8. So 4 to 8. So this one is yes. So these would both simplify to 1/2, so the scale factor is 1/2, and it's yes. Okay, let's figure this out with algebra now. So number 7, the polygons are similar, so we're already saying they are. Find the value of each variable. So we've got an x to find and a y. So I think I would just look at it and I would go, well, it's on a scale factor of 4 to 6 because find two sides that are corresponding, so 4 to 6. So our ratio, if you simplify that, it needs to be 2/3. So we're looking for a ratio of 2 to 3. So 2 to 3 equals y over 12. 2 to 3 equals y over 12. You can do the bat and the ball and cross multiply. That'd be 24 divided by 3, so y would be 8. For x, 2 to 3 equals x to 9. 2 to 3 equals x to 9. Be sure you don't put 9 over x. If you're going the smaller to the bigger, then you need to put the smaller to the bigger as well. And then you can do the bat and the ball. 18 divided by 3 is 6, so x is 6. All right, number 8. So if these are similar, it looks like it is on a scale factor of, I think 9 is corresponding with my 15. So 9/15. So those both divide evenly by 3. So it would be 3/5. So my scale factor I'm looking for is 3/5. So if I need to find A, it needs to be 3/5 of 12. So 3/5 of 12 would be, did I set that up right? 3/5 A. No, A to here, oh yeah, is 12. So let's see, 3 times 12. It's just that it won't come out evenly, so I was second guessing myself. So 36 divided by 5 will not come out evenly, but it's close. 7.2, it's fine. 7.2 is A, and then for B, 3/5 equals B over 10. So 3/5 equals B over 10. 30 divided by 5 is 6. Okay, let's turn the page and try just a few more. Number 9, you want to enlarge a 3 by 5 inch photo. The paper you will print on is 8.5 inches by 14 inches. What is the largest the photo can be? So if it's a 3 by 5, and the paper we will print on is 8.5 by 14, basically what we're looking for is how many times can you take 3 to get 8.5? How many times can you get 5 to get 14? So I'm going to work backwards and I'm going to divide. So I would take 8.5 and divide by 3. Oops. And I got about 2.83. So I would also, just to double check that, I would take 14 and divide by 5, and it would be 2.8. So, and that's about what the other one was. So what's the largest size the photo can be? 2.8 times in size. So it could be 2.8 times magnified. Okay, for art class, you need to make a scale drawing of the Parthenon using the scale 1 inch equals 5 feet. 1 inch equals 5 feet. There's your ratio. The Parthenon is actually 228 feet long. So if it is actually 228 feet, and notice I put my feet across from feet, how many inches is the actual scale drawing? So you can do the bat and the ball. 228 times 1 divided by 5 is 45.6. So it should be, I don't think I did that right. For art class, okay, we're going to look at number 10 again. For art class, you need to make a scale drawing of the Parthenon. Did I do that right? 1 inch is 5 feet. The Parthenon is actually 228 feet. So you know what? I'm going to leave this. I'm going to actually, I wonder if I needed to convert that. Can I put out a challenge for you guys? Doing it this way, I got 45.6 feet, but that actually doesn't make logical sense. I'm not going to have a drawing that's 45 feet long. So I'm going to challenge you guys to fix what I did here and then come tell me in class, because I would love to hear your answers. Okay, and then this last one, let's go ahead and do, I know you can set it up the same. The scale is 1 inch to 20 miles, so 1 inch per 20 miles. On the map, the distance Ella must drive is 4.25 inches. So we're going to put that one up top because inches is lined up with inches. How many miles is this? You can definitely go ahead and cross multiply there. So 4.25 times 20 is 85, and you can divide by 1, but that's just going to be 85. So this would actually be 85 miles. Okay, I know that one is good. Come back to number 10 and tell me what you get. Number 12, find the value of z. So again, it's just the same. It's just that now we have a little bit more algebra. So you're going to put, whenever you cross multiply, you're going to have to distribute. So I would set it up maybe the long side over the short side that are on either sides of this right angle. So long over short for me, I'm going to set up, you don't have to like this, but I'm going to go 3 over z, and that is long over short. So I need to, on the other one, put long over short. So it needs to be 9 over z plus 4. So 9 over z plus 4. And when you cross multiply, it's going to be a little bit more work because there is 3 times this, the quantity of z plus 4, which means I'm going to have to distribute. So 9 times z is just 9z. Distributing this would be 3z plus 12. And then I'm going to minus 3z on both sides, which is 6z equals 12. That means divide both sides by 6. Z equals 2. So that's all we had to do. Z equals 2. Oh, and then it says find the scale factor of the polygons. So if z is 2, the scale factor is 3 to 2. Oh, no. This is the whole thing to this whole thing. Sorry. The long side is 3. The other long side is 9. 3 to 9 is 3 times bigger. So it's on a 3 to 1 scale. All right, and we didn't really need 2 to do that, but that's okay. All right, scale factor of ABCD to EFGH is 7 to 20. What is the scale factor of EFGH to ABCD? Well, that's just going the other direction. So if it first wanted it in this order and it was 7 to 20, and now we're flipping it in this order, we just want 20 to 7. Okay, number 14. In the diagram below, so these are the pictures we're looking at, find each of the following. We first need the scale factor of triangle NOP in this order to WXY. So we need the little one to the big one. So this is, I see a side. Let's see what our corresponding sides are. I'm going to go 4 to 10. So if that is 4 to 10, always simplify if you can your ratio. You can divide both sides by, or top and bottom by 2, which would be 2/5. So you can either write it as a fraction or you can write it like this. 2 to 5 is the ratio. That's the scale factor, 2/5. Okay, the measure of angle X would be 58 degrees, because even though the side lengths are different, if they are similar, the degrees in each corner in each vertex is the same. So this one is 58 degrees. Measure of angle Y down here would be 58 plus 49 plus question mark equals 180. So we're going to take 180 in our calculator and subtract 49 and subtract 58. And I got 73. So this is 73, means this is also 73. So measure of angle Y is 73 degrees. Okay, the ratio of side lengths NP over WY. NP, we don't know. WY is 12. So if we know that the scale factor is 2 to 5, I'm going to go ahead and set it up 2 to 5. And what we're looking for is NP, which we don't know. But we know WY is 12. So you can cross multiply and do the bat and the ball. 2 times 12 is 24. Divided by 5 is 4.8. So X is 4.8. And remember, X is what we were looking for, was NP. And if it wants it NP over this, then we need to go ahead and put 4.8 over 12. All right, WX is the next one we're looking for. So WX. So we can use 2 to 5 again, but this time set it up 6 to X, because this is the side length we're looking for. 6 to X. And the reason I put 6 on top is because it's the smaller one, and so the smaller one is 2 to 5. So let's cross multiply. 6 times 5 is 30, divided by 2 would be 15. So WX length is 15. All right, and then NP, we already calculated it earlier. It would be 4.8. All right, and then the last one, let's see. A company makes rugs. Their smallest rug is a 2 feet by 3 feet rectangle. Their largest rug is a similar rectangle. If one of their largest rug sides is 18 feet, what are the possible dimensions? So if you have a 2 by 3, you could either have 18 up here, or you could have a 2 by 3 and you could have 18 down here. And those are the only two possibilities. So I would just do the bat and the ball with both of them. 18 times 3 divided by 2 is 27. So the possible dimensions are 18 by 27, or let's do this one. 18 times 2 divided by 3 is 12. So you could have 12 by 18.